Hello again, Trig. This is Q4 week 2. We are going to be working on some things with matrices and systems of equations. We're going to put all this stuff together. So we've done systems of equations before, probably Algebra 2, and we've been working on some matrices. I know we did some in Algebra 2 also. So we're going to go over a couple of things today. So the systems we're going to be working with today are going to be in 3 variables. If we have 3 variables, that means we really need 3 different equations to be able to real easily find the solution. So let's do an example of just simple solving by substitution. It's going to be a pretty easy example to start with, and then we'll crank it up from there. Okay, solving by substitution. So hopefully this looks familiar to what you've done before. So here's our system. Our system is x minus 2y plus z equals 7, y minus 2z equals negative 7, and z equals 3. Well, when I look at this, I immediately notice this last equation here. I love it when I've got something as simple as this. This one, I can real easily know that, well, my z value is 3. So this is going to make it helpful. I'm going to take this and I'm going to substitute it into this second equation. Why would I pick the second equation? Well, it's only got y and z. So if I substitute in there, I'll easily be able to solve for y. So y minus 2 times 3 equals negative 7. So then just use your basic algebra skills, and we know that this is y minus 6 equals negative 7. Add 6 to both sides, and we end up with y equals negative 1. This is great, because now I have 2 values of the variables. I've got z is 3, and y is negative 1. So then, to find the last value, I'm going to take these two, y is negative 1 and z is 3, and plug it into this top equation, this first one. So let's get a little bit more space here. So if I plug these in, I'm going to have x, oops, if I get the pen, x minus 2 times negative 1 plus 3 equals 7. So if we work this out, x plus 2 plus 3 equals 7. And I have 2 plus 3 is 5, so x plus 5 is 7. And then we'll get x is equal to 2. So then we have our solution to this system of equations. X is 2, y is negative 1, z is 3. I can also write it, when we have 2 numbers, we call it an ordered pair. I can have an ordered triple when I end up with 3 variables. So my ordered triple would go in order x, y, z. So 2, negative 1, 3 would be my solution. So if we go back and look at this system, the original one that we had up here, this is written in what we call triangular form. Triangular form, if you think about this, it kind of makes a triangle because it's got 3 variables in the first equation, 2 of the variables in the second, and 1 in the third. Triangular form is great because it is really easy to see what the solution is to this system. You might not be able to see it, but you can easily find it. So one of the things that we want to be able to do is be able to transform any system into a triangular form. As you can see, this is far easier than some of the ones that we're going to run across. So we're going to look at what does it take to transform any system into triangular form. So the way we do that is using a process called Gaussian elimination, named after an old German guy named Gauss. So Gaussian elimination helps us transform any system into triangular form. So there are some operations that we need and we can do. So any of these operations will produce an equivalent system of linear equations, and all we're really trying to do with Gaussian elimination is produce an equivalent system that's just in triangular form. So operations needed are these. Number one, we can interchange any two equations in the system. That's helpful because if you remember the triangular form, it's in a very specific order, 3, 2, 1. So if I have it out of order, then I can flip it around. Number two, multiply or divide one of the equations by any non-zero real number. And the third operation add a multiple of one equation to any other equation in the system. So add a multiple of one equation to any other equation in the system. Okay, so let's use these three operations or properties, if you will, and do an example. And so we're going to do some Gaussian elimination next. Okay, let's slide over and find some more space. Example 2. Gaussian elimination. Okay, we want to solve this system. So here's our system. It says x minus 2y plus z equals 7. 3x minus 5y plus z equals 14. 2x minus 2y minus z equals 3. So I look and I start thinking, how am I going to get some of these things to be similar to each other? How am I going to get some of these things to like shift around? So the first thing I'm going to do is I'm going to take this first equation right here, and I'm going to multiply everything here by -3. So it'll be -3x plus 6y minus 3z equals -21. Then what I'm going to do is I'm going to add this second equation to that. Why am I going to do that? Well, if you look at the first term, it's 3x. So I'm going to add these. Whatever solution I get, I'm going to replace this second equation with that. So 3x minus 5y plus z equals 14. Let's add those together. That gives me 0. 6y minus 5y is going to be just a y. -3z plus z gives me a -2z equals -7. So don't worry about that first 0. So I'm going to replace this second equation with this new equation here. Cool, so I replaced the second equation. I left the first and third ones as they are for now. So let's think, what else can we do? So now I'm looking at this first and third equations. Well, I've got a coefficient of 2 on this third equation and my x, and this x in my first equation doesn't. So I'm going to take this first equation, I'm going to multiply everything up here by -2. Let's see, so that will give us -2x plus 4y minus 2z equals -14. So I'm going to now add the first and third, and then I'm going to replace this third equation with whatever I get. So 2x minus 2y minus z equals 3. We're going to combine these. So that gives me 0. 4y minus 2y is going to be 2y. -2z minus 2z, so it'll be -3z. And then -14 plus 3 should be -11. So now I'm going to replace this third equation with this one. I can do that because these are equivalent forms. Okay, now let's see if we can figure out what else to do so that we can end up with triangular form. It's looking okay so far. I've got 3 variables up here, 2 variables, and then 2 variables. So I gotta do something to get rid of one of these variables. So I got x, y, z in the first one, y, z in the second one, and I probably want to have just z in the third one. So I'm looking at these, and if I want to get rid of this y term, I think I'm probably going to have to take this second equation right here and multiply it by -2. And then I can add it with the third one, and that will get rid of my y term, and I should have just a z left. So let's see. So -2y plus 4z equals 14. I'm going to add it with this third one. 2y minus 3z equals -11. So let's see what we get. That's going to go away. Then I've got z equals 3. Nice. So I'm going to take this z equals 3 and replace this third equation with it. So this is looking really good. This is what we want to see. So for a system of equations that has exactly one solution, this system is triangular form. It's great. So in this case, the leading term of each of these equations has a coefficient of 1. I love that. The second equation has at most 2 variables, one of which is not the one in the third. The third equation only has 1 variable. And the first one has all 3. So all 3 2, 1. This would not help me if my second equation had x and y, but no z. That wouldn't work. So you want to make sure that you have whatever you have in your third equation has to continue up into your second. Whatever you have in your second equation, of course, has to continue up into your third. If you think about it kind of going step by step like that, then you'll hopefully be able to see what steps you should take to do some Gaussian elimination. So I'm going to give y'all a couple of examples of this to try, and this is what we're going to work on for this week. We're going to take this and turn it into matrix form next week and see how matrices can help us with this kind of stuff. So make sure you write down questions, look for your examples in your classwork, and hopefully I will see you on Zoom soon. Oh yeah, one more thing to note real quick before we go. If you ever end up getting a system of equations and you end up with something, if you end up with something that looks like this, like maybe x minus 3y plus z equals 4, negative y minus 4z equals 7, and then you do everything you can, and your third equation ends up with something like 0 equals 2, not z, 2. If you end up with something like this, and you have something like 0 equals 2, 0 equals 2 is not true, can't ever be true, so we have to conclude that this system has no solution. So if you end up with something like this, probably has no solution. Cool? Awesome. See y'all soon.